Okay, so we're looking at velocity versus time graphs, and here I'm going to start with the graph. So this graph has an object that starts with 0 velocity, and then the velocity increases to 1 meter per second, and then it increases to 2 meters per second, and then it increases to 3 meters per second, and then it increases to 4 meters per second, and then it continues at 4 meters per second, and continues at 4 meters per second, and then starts to slow down 3 meters per second, 2 meters per second, 1 meter per second, 0 meters per second. But then it doesn't stay at 0. Now it starts going -1, -2, -3, -4 meters per second. So what is that telling us? Positive velocities mean that it's moving forward. Negative velocities mean that it's moving backwards. So let's see what this would look like moving our little car around. And I'll do my best. I'm not saying that this is going to be perfect, but let me fix this graph. All right, so this car starts out at rest and then speeds up to 4 meters per second. So go, it starts out really slow and it speeds up to 4 meters per second, and then it keeps going at 4 meters per second, and then it slows down, stops, and then starts speeding up in the negative direction until we get to the end of the motion. Now let me try that again. Starts out at rest, increases its speed, then maintains that constant speed, and then starts to slow down, stops, and then starts speeding up in the opposite direction. Okay, so let's look at our graph and see what we can learn from this graph. So first of all, position. Actually, this is impossible. We cannot learn the position of the object from a velocity graph because we could have the exact same velocity graph if the car started here and sped up, continued to move at constant speed, slowed down, and then reversed and went back a little bit. The whole point is we can't tell what the initial position is, so we can't tell from this velocity graph, we can't tell where the object is. What we can do, though, is get the displacement. Okay, and here's the deal. Because velocity is equal to the derivative of position, if we integrate both sides of this equation, the integral of v dt is equal to the integral of x dot dt. Now this is the integral of x dot dt is this is called the fundamental theorem of calculus. The fundamental theorem of calculus says that this integral is equal to x final minus x initial. That is the displacement. So displacement is the integral of velocity. So in order to find displacement, we have to integrate, which means find the area. So displacement, like average velocity, like average acceleration, always has a starting and an ending time. So let's say we wanted to find the displacement from, from t equals 1 second to t equals 5 seconds. what we would need to do then is to find the area bounded by the line t equals 1 second, t equals 5 seconds, the velocity graph itself, and the zero line. So anything above the zero line is positive for my displacement. Anything below the zero line is negative for my displacement. So if I want to integrate this thing, graphically, what integration means is finding the area. So if I want to find the area, the easiest thing for me to do is to break this up into triangles and rectangles. This rectangle here has a height of 4 meters per second and a base of 1 second. So this rectangle has an area of 4 meters. This is a triangle. It's got a height of 4 and a base of 1.5. So a triangle, 1/2 base times height, is going to be equal to 3 meters. Is that right? Maybe I did that wrong. Sorry. The height is 4. The base is 1.5. So I've got 1/2 times 4 times 1.5 is 3 meters. Okay, yes. Okay, and then the last one is also a triangle. It's got a height of -4, a base of 1.5. So we got 0.5 times -4 times 1.5. So this thing has an area of -3 meters. So the total displacement from 1 to 5 seconds would be 4 meters. And I actually marked this out on my graph. The car started at -4 meters, and we can actually fill in the rest of this chart. This area here is 2 meters for that triangle. So in the first second, it went forward 2 meters. In the second second, it went forward an additional 4 meters. In the next second and a half, it went forward an additional 3 meters, and then it went backwards 3 meters. Yeah, okay. Anyway, displacement is area. If I wanted to know the displacement from 0 to 2 seconds, it would be 6 meters. The 2 meters from 0 to 1 seconds, and the 4 meters from 1 to 2 seconds. All right, that's displacement. If we want the average velocity, that's just going to be displacement divided by time. So we calculate our displacement by doing the area, and then we divide by time. If we want the velocity right now, we just need to read the graph. So for example, if I want to know what's the velocity at 2 seconds, I start at 2 seconds, I find the velocity is 4 meters per second. If I want to know the velocity at 3.5 seconds, here at 3.5 seconds, the velocity is 0. Okay, next, acceleration. Well, we can do average acceleration. The average acceleration is going to be the final velocity minus the initial velocity divided by time. So to do that, if I wanted to know the average acceleration from 0 to 2 seconds, I'd say, okay, my final velocity is 4, my initial velocity is 0, and so the average acceleration is 4 minus 0 divided by 2 seconds, and that would give me the average acceleration. If I want to know the instantaneous acceleration, that is the acceleration right now at, let's say, let's do at 3.5 seconds. Okay, let's find the acceleration at 3.5 seconds. So to find the acceleration at 3.5 seconds, the first thing I'm going to do is just find that point, the 3.5 seconds. That's right here. Now the velocity is 0, but what's the acceleration? Acceleration is the slope of the line, because acceleration is the derivative of velocity, so acceleration is going to be the slope of the velocity graph. So in this case, I need to find the straight line that this point is on, and I need to find 2 points on that line to find the slope. So let's look at this point and this point. So we've got a final velocity of -4 and an initial velocity of +4. Or let's see, let's do slope is rise over run. So the rise here is -8 because it goes from +4 to -4. So the rise is -8, and the run is 3, 4, 5 seconds. So the run is 3 seconds. So the average acceleration would be -8 over 3, which is -2.666 meters per second squared. So in order to find, and by the way, I'd have the same acceleration here, and the same acceleration here, and the same acceleration here, and the same acceleration here. Everywhere that has the same slope has the same acceleration. So this whole line has an acceleration of -8/3. This whole line has an acceleration of 0, and this whole line has an acceleration of +4 meters per second squared. Okay. Okay, one more thing before we stop this video. I want to point out that this whole line has an acceleration of -8/3 of -2.66 meters per second squared. And I want to point out something important. It started out at +4 meters per second, and it goes down to 0. So during this part of the graph, the object is slowing down. Okay, but when it gets to 0, then it starts going backwards, and it starts out going backwards slowly, and now it's going faster and faster and faster backwards, because -4 meters per second is faster than -2 meters per second. So it was slowing down during this part of the graph, but it was speeding up during that part of the graph, and yet the acceleration was negative the entire time. Negative means that the slope is going down. But if you already have a negative velocity and then you have a downward slope, that means your negative velocity is getting even faster. So a negative acceleration can mean you're slowing down if you're moving forward, but if you're moving backwards and you have a negative acceleration, it means you're speeding up. So in general, speeding up means that the velocity and the acceleration have the same sign. That is, if your velocity is positive and your acceleration is positive, then you're speeding up. If your velocity is negative and your acceleration is negative, you're speeding up. Slowing down means velocity and acceleration have opposite sign. If your velocity is positive and your acceleration is negative, then you're slowing down. If your velocity is negative and your acceleration is positive, then you're slowing down. Okay, that is all for this video.